Hey guys, welcome to Grade Gain, where every student can make progress. Now, I want to introduce you to some friends of mine today. Now, I know you're sitting at home going, what? He's a science teacher. He hasn't got any friends. Look at him. He's home on his own. But I have. These friends are really, really helpful friends. They will help you with your exams. And here they are, highlighters. Okay? Yep, I know, they're not real friends, but hey, they're friends that will help you get the best grades that you can in your exam, and that's what we're here for. So what I want to do is I want to go through some exam questions and show you how to use the highlighters to help you answer some calculations questions. Now, in physics and chemistry, calculations questions often come up, so you can guarantee that these babies will get used a lot in your exam. So without further ado, let's crack on and see how they can help us. Let's start with an easy one. Here, this is an exam question from an AQA paper. A student set up the electrical circuit shown in figure 9. There we go. Now, the ammeter displays a reading of 0.1 ammeters. Calculate the potential difference across the 45 ohm resistor. So at this point, we break out our friends. Here, I'm going to use green for my current. So 0.1 amps. I'm going to use orange for the potential difference. And I'm going to use pink for the resistor. So, I know that I need Ohm's law. V equals I times R. Potential difference is V. Current is I, R is resistance. So now I colour code my formula with the same colours that I've got here. So potential difference is orange, current is green, and resistance is pink. So I now put in the numbers that I have. Well, I don't have a number for V, so I replace it with the letter V. I do have a number for current, so I replace the I with 0.1 and the R with 45. This question is out of 2 marks, so already I have secured 1 mark. Now all I've got to do is break out my calculator, work out the answer, and write the answer there. So with my trusty calculator, 0.1 multiplied by 45 equals 4.5 volts. That was quite an easy question because there were only 3 terms there, and it was fairly obvious where I got the information from. We're now going to look at a much more complicated question. This is from the very end of the same higher tier paper. Here it is, question 13.3. Now we can see that there is a lot of information in this, so we're going to go through it nice and slowly. So the charge, that's going to be useful information, that flows through the new shower in 300 seconds is 18,000 coulombs. Notice how they've split up the charge, which tells us what it is, and the number. They're a long way apart, but I've highlighted them in the same colour, so we know that they are the same thing. It tells us 300 seconds, and it tells us a power of 13.8 kilowatts. They then want us to calculate resistance. So we've got there 3 pieces of information. Charge is Q, time is always T, P is power. Now, there isn't an obvious formula that links these things, with resistance being R, but I do know that P equals I squared R, and I also know that Q equals IT. So let's see if those formulae are any help to me. So power, that's orange. Current, well, I haven't got current in the question at all, so I can't highlight that one at the moment. Resistance, I have got. Q, that's charge, I've got that. And time T, I've got that. Now we can see that I don't know I for this one to help me get to R, but I do know two pieces of information here that will help me solve for I, which means I can then substitute in there. So put the numbers in to start with. 18,000 is equal to I times 300. And at that point, we've secured ourselves 1 mark. I rearrange this. I is 18,000 over 300. Well, I can cancel out 2 lots of the zeros. So 180 divided by 3 is 60. So I've got a current of 60 amps. And at that point now, I've secured a second mark. So we've got 1 there, and we've got 1 there. If I stop now, nothing lost. I've got 2 marks. I'm happy. But I need to go a stage further to calculate the resistance. So now we put in the numbers that we do know. We've got 13.8 kilowatts. Think about that, kilo. That means 13.8 thousand watts. And I've got to put this into watts. So that's 13,800 watts is equal to 60 squared times R. And at that point, I've secured myself a 3rd mark. Now I rearrange it. 13,800 divided by 60 squared is equal to R. So again, I'm going to break out my trusty calculator at this point. Here it is. So I've got 60 times 60 is 3,600. So I've got 13,800 divided by 3,600. Well, I can get rid of those zeros straight away, can't I? So I've got 138 divided by 36, which gives me a resistance of 3.8 ohms. There we go. That's how our friends can help us with our GCSEs. There they are, the highlighters, saviours of the day. They've managed to produce some answers for us from what looked like quite a complicated question. But because of the highlighters, it just made those answers pop out of the page. That's partly to do with the fact that I've used the fluorescent colours. Now you can get some really cool highlighters. I particularly like the pastel ones that are being done at the moment. I don't know about you. What's your favourite one? Let me know in the comments below. What's your favourite colour highlighter? Bit of a bizarre one, but hey, why not? Find out. Don't forget guys, you can subscribe to my channel, okay? Grade Gain, where every student can make progress. And also check out some of the required practical videos. They're there for you. They'll help you. And I'll be producing more of these videos as we go through the year. So don't forget to subscribe. Make sure you hit the notification button as well, so you know when I've uploaded a new video. Okay, well, good luck with your GCSEs, guys, and don't forget those highlighters. All right, take care. See ya.